All right, so we're going to be talking about inverses on worksheet 12 today. We're going to talk about whether an inverse is, whether a function is one-to-one and what that means. It means that the function's inverse would also be a function. We're going to find the equation of the inverse and domain restrictions. We're going to talk about verifying whether two equations are inverses of each other, but I actually did not put that on the quiz. And I can graph a function and its inverse, and that is on the quiz. All right, but here's today's warm-up, because some of you need to retake 1.4 on graph analysis. So I need you to eyeball quickly, because I don't want to do this on the calculator. The maximum point, anybody want to give me an ordered pair? .5, 1, 2, 3, 4, 5, 6, 7, 8, or 8.5, I really don't care. Minimum, -1, -2.5, I don't know. Okay, so increasing. This is on the quiz again, because today we're going to talk about increasing, decreasing for power function. No, not today. Anyway, eventually. This is decreasing, this is increasing, this is decreasing. Are we good? Okay, so how do we state an increasing interval? Do you remember what we have to use? The x's, right? So this is -1 and this is +2.5 for x's. So from -1 to 2.5, it was increasing. And decreasing? (2.5 to infinity on the right to -1 over here. All right, inflection point. Somebody want to pick an inflection point from our graph? On an actual graph on your calculator, you just hit trace and trace along to where you think it switches its bend from this up to down. So somewhere in here, can I just pick that? Can someone come up with an ordered pair for me there? Haley, this is for you at the end of class. Is that 1,4? Okay, so our inflection point is 1,4. Whatever we pick for that inflection point, two things. One, it should be on the actual graph, so make sure you're tracing along. And second of all, we use that x value to determine the concavity. So if this is x equals 1, what's it doing over here to the left of that? Yes, it's up. It's happy it's going this way from -infinity until 1. And it's down from that inflection point to the right. Remember, increasing, decreasing, concave up, concave down are all x intervals. So you're talking about a left to right situation. Okay, end behavior. On the quiz, the next quiz, it looks like this. I don't know if that's going to mess anybody up. It shouldn't, but it's more in the limit order. So it's saying y is doing what as x is doing what. So if you want to talk about the left end, that would be an x that's going left. And what's that left end doing? It's going up, so the y values are increasing or going up to infinity. Okay, how do we do the other one? The other one has an x value of +infinity, so that you're going off to the right, and that end is going down, so the y's are getting negative. All right, good enough? I didn't do everything. We didn't do zeros, but we're good. All right, so inverses. Anybody remember anything about inverses? No. Okay, the inverse is when you switch the x and the y. Okay, so if I had an ordered pair like 2, 7, the inverse would have an ordered pair of 7, 2. If the domain for a function was these x values, and the range was this, the inverse would do what? Flip those. Domain would become range, range would become domain, because domain is x, range is y, they would flip. All right. Now, this particular relation that they show here, this is a parabola. They switched all the ordered pairs, the x's and y's, and it became this green one going this way. What do you notice about the green one, though? Is it a function? No. Okay. So every function, this one was a function, its inverse is no longer a function if the original function fails the horizontal line test. Okay. So the original function here, the blue one, passes the vertical line test, but if I draw a horizontal line, it crosses more than once. That means it's not one-to-one. So it means when I do an inverse, it's not going to be a function. All right. So notice these inverses. Oh, we didn't talk about that. They are reflections of each other over this red line. Anybody know the equation of that red line? It's even written right there. That's the line y equals x. So they're reflected across the line y equals x because we literally do what with the x and y? Switch them. So all the y's become x's, the x's become y's. So they reflect across that line y equals x. All right, this relationship is true of all graphs and their inverses. We're most interested in functions with inverse relations that are also functions. If the inverse relation of a function is an inverse function, they're both functions, we use f and this to read the inverse of f. Now, that's confusing because very soon, like tomorrow, we're going to start talking about negative exponents. This is not a negative exponent, okay? This is like again, mathematician decided this means f of x and this means f of x's inverse. It does not equal 1 over f of x, okay? It has nothing to do with moving something to the denominator. It's just a notation. All right, not all functions have inverse functions. We just talked about that. It would have to pass the horizontal line test. So this particular blue function right here passes both a vertical and horizontal line test. So then it is called a one-to-one function, because if I were to do its inverse, which would, like, say this was -5, it would be over here. Say this was +2, it would switch over here, and it would end up looking like this, I think. Does that look like it flipped across this line right here, guys? Okay, so the inverse would still be a function. It would pass the vertical line test. All right, so you have it phrased this way at the top of your paper. It says one more time, two relations are inverse functions if and only if one contains BA when the other contains AB. So you're switching the X and Y ordered pairs. If the inverse of a function is also a function, you write it like this. A function has an inverse function, okay, not a relation, but a function, if and only if it passes a horizontal line test. If a function passes the horizontal line test, it is said to be one-to-one because every x has only one y. It passes vertical and horizontal line test, meaning the inverse will be a function too. All right, so graph each function using graphing calculator, apply the horizontal line test to determine if its function is an inverse. If its inverse function exists, in other words, is it one-to-one, right? Yes or no? Okay, so they graphed this nightmare and it looked like this. Is it going to pass the horizontal line test? No. So the inverse function does not exist. All right, so let's try these. 1 over x, graph it on your calculator. What's it look like? It's actually a parent function. Some of you might know. the reciprocal function. So does it have an inverse? That is a function. Does it pass horizontal and vertical line tests? Yes, it does. So yes, the inverse would be a function. It's actually its own inverse. Do you notice if I try to reflect it across that line right there, it's just going to flip. So if I put a 1 in, what do I get out, guys? If I put a 2 in, I get out a, no, 1 divided by 2 would be 1/2. But if I put a 1/2 into the original function, what's 1 divided into halves? How many halves is there? 2. So it's already its own inverse. Okay, but it does have an inverse. What about this one? Can somebody tell me what that looks like? You shouldn't need your calculator even, right? It's a parabola that's shifted down. Okay, is that going to have a function that's an inverse? Okay, it has a inverse, but it's only a relation. If I, yes, it would be over here doing this, but it would fail the vertical line test, right? So the original function, the blue one, fails the horizontal line test, so it does not have an inverse function, it has an inverse relation. All right, I don't think I know what this looks like. One divided by the square root of x minus 4, zoom 6 maybe? Does it show anything? Oh, interesting. It's like this. Okay. So what do you think? Does it pass the vertical line test? Does it pass the horizontal line test? The questions for some of us is this getting perfectly horizontal or not? And I think if you trace there, it's not. So therefore, I think yes, it would pass. Anybody know what it would look like if I reflected across this line? Is it going to maybe do that? Does that look right, guys? Does that look like it's symmetric across that line now? And that would pass the vertical line test, so I'm going with yes. All right. If a function passes the horizontal line test, then it is said to be 1-to-1. We discussed that. It means it has an inverse that's also a function because every x has only one y and every y is only one x if it has one at all, whatever. Okay. What am I supposed to be doing here? Oh, that's the same thing. It says, this little note is just about the fact that this notation, okay, does not mean 1 over f of x, okay? It has nothing to do with moving something to the denominator. All right, so steps to find an inverse. To find an inverse function algebraically, use the horizontal line test to confirm it exists. Replace the f of x with a y, okay? But then you interchange the x and the y. Then you solve for y, and if you're all done and it has an inverse function, you replace it with this notation. And I'm not going to be picky about that last part. If you leave it y, I'll be okay. And then state any restrictions on the domain. All right, so here's the starting question. I'll pretend I don't have it worked out just to show you. You would replace the f of x with a y. And then I would need to isolate the x. So I would subtract 3. And then what would I have to do to get rid of that 1/4? Trying to get the x by itself. Multiply everything by 4 on both sides. So I'd end up over here with 4y minus 12, and this would just be x. And then because this passed the horizontal line test, I am allowed... Did I switch the x and y? Okay. We did it right. I just didn't use the right notation. Okay, so the first thing is I switched the f of x to a y. The second thing I'm supposed to do is switch the x and y. Then I'm supposed to solve for the y, which is what I just did. I just used the wrong variable because I apparently wanted to confuse you all. All right, now this is the inverse. It is a function, so I'm allowed to write it like this, which I'm okay if you didn't even use that last step, which is what they have here. Okay, so it's really important that you switch the x and y. Let me confuse you a little more on that. All right, so that one was done for us. Anybody know what the inverse would look like? If this was originally 0, 3, what point would it be on the inverse function? 3, 0, okay? If this point was originally, if I put in a 0, negative 12, okay? So this was negative 12, 0. The new function would have 0, negative 12, and it would look like this. Does that seem okay? Does it cross? Do they reflect across that line? Okay, I'm trying to combine ideas here for you. All right, so we're determined whether it has an inverse function. If it does, find the inverse and state any domain restrictions. All right. So right now the domain and range are all real numbers because it's a line, right? So we should be good. If we graphed it, it would look like this. Passes the horizontal line test. So how do we find the inverse? This is currently a y, so now what do we have to do? Yes, we write x equals 2y minus 4. We switch the x and the y. Then we have to solve for y all over again. What's that going to look like? Get the y by itself, guys. What are we going to do? Add 4. And then divide by 2. You could write it like this. Or you could divide each piece by 2, so you'd end up with 1/2 x plus 2. They're both right. Is the inverse a function? Did the original pass the horizontal line test? Yes, so it was 1 to 1, so the inverse is a function. So I could require you to write it with this notation, but I really don't care. Either one of those is correct. All right, what does the original function on number 5 look like? Shouldn't need a graph. Has an x squared, so what shape is it? Parabola whose vertex is at 1, 2. So over 1, up 2, somewhere up here is a parabola. Does that pass the horizontal line test? No. Okay. If we were to attempt to find the inverse equation, you would get an equation, but it would have a plus or minus. I think, what does it say? If it does, find the inverse function, okay? This is not 1 to 1, so we're not required to do anything. Means the inverse is not a function. We're going to talk more about this in a couple minutes, but in calculus, you will have to do a lot of restricting the original domain to make this 1 to 1. Does anybody know what we could do so that this was 1 to 1? What could we cut off? Yeah, right now this vertex is at 1, 2. If I said I want x values only greater than or equal to 1, so I cut off this half, would it then be something that would have an inverse function? It would be 1 to 1. Okay, that's the kind of thing you have to talk about in a little bit, but we don't have to do that for this question. All right, these two questions, no, I'm kidding. These aren't bad. All right, so graph this maybe? I'm thinking it looks like this maybe? Anybody getting something like that? You should have parentheses down here. 5 divided by the quantity x minus 2. My graph is pretty good. Okay, does it pass the horizontal line test? Yes. So we can switch the x and the y, and it will say x equals 5 over y minus 2. But now we need to isolate y. Any ideas? What? Okay. Yes. Can we just kind of think of it as a cross multiply, guys? Would that be okay if I describe it that way? Which is multiplying by the reciprocal. But, so I'm going to do x times y minus 2, and this way would be 5 times 1. Okay. We're trying to get the y by itself, so we can distribute or not distribute. It's up to you. Would most of you distribute? Just let me ask it that way. So if I distributed, I'd have this. Okay, still trying to get the y by itself. What do you want me to do? So we'd have xy equals 5 plus 2x. Divide by x. So I have y equals 5 plus 2x over x. Anybody know how else that could be written? Yes. Because if you put the 5 over the x and then the 2x over the x, it would just be this, which is what you could have done here, guys. Look, if I had decided to divide by the x here, and then I would have added the 2 over here, same thing. So either one is correct. My job is to make sure your answer is equivalent. You don't have to come up with all the possible ways to write it. Now, what did we decide? Is this an inverse function? Was the original 1-to-1? Yes, right? So we can write it as 5 plus 2x over x. Or if you wanted, you could write it as 5 over x plus 2. But you don't need both. One or the other is fine. All right. There's another question here. Way back up here. Anybody know what this looks like? Squiggly cubic thing up at 4, right? Is that 1-to-1? Does it pass a horizontal line test and a vertical line test? Yes, it does. So right now it says y equals x cubed plus 3. I need to switch. So I have x equals y cubed plus 4. I think I just said plus 3, sorry. What do I do first? So I'll have x minus 4 equals y cubed. And then cube root both sides. So I'll have the cube root of x minus 4 equals y. If I graph that on my calculator, guys, guess what? Looks like this. Does that seem like it's flipped across that line right there? Okay. So how should I write this, though? And I'm not going to be picky about this on the quiz, but the inverse function is cubed root of x minus 4. If you just left it at the y stage, I'm okay. Because the reason I'm okay with you stopping is because they get really tricky. And these are on the final, they're on the summative, this next summative, they're on the post-assessment. Okay, when there is an x in 2 places, when we switch the x and y, we're going to have a y in 2 places. So it's going to require some steps, okay? It's going to require factoring. Just remember that. Okay, now what we're going to do is, this is, oh, should we graph it first? How would I type this in to graph this first one? Yep, I'd have y equals, oh my goodness, I have a lot of junk in here. X divided by parenthesis x plus 4. Good job. Oops, supposed to be a 4, right? Was it a 4? Okay, so it looks like this. Passing the vertical and horizontal line test, guys? Yes? So we can go ahead and switch this to x, and these both become y's. Okay, so before we do the factoring thing, there's 2 steps. We're going to cross multiply. Then we're going to isolate on one side everything that has a y in it, and then we're going to factor. Okay, so cross multiply this, and what will it say? Okay, so he went this way first. 1y equals x times the quantity y plus 4. We're going to need to distribute, so we'll have xy plus 4x over here. Now we're supposed to isolate everything with a y. What does that mean? Okay, but first we're going to get it all on one side, and then we're going to factor it out. So we're going to have y, and we're going to subtract an xy over there. Okay, now I wrote factor. Why do I write factor? Factor out a y. What's left over here is, be careful. Oh, you're making me sad. If I factor a y out of this, what do I get? Right? If I have to be able to distribute this back, if it was just this, when I multiplied it back together, I'd get negative xy. Is that what I started with? No, I had 2 terms, so I need 2 terms after I take out the y. All right, and I have over here equals 4x. What am I trying to get by itself? So what do I need to do? Divide, right? It's multiplied here, so I want to divide by 1 minus x. It is a lot of steps. 4x over 1 minus x, which can be written like this. And remember a second ago I said I'm not going to worry about you writing it that way? This is the kind of problem because there's enough steps without rewriting it at the end, right? So I'm okay if you don't rewrite it at the end. Okay, so please make sure you wrote these steps down somewhere. So you're going to cross multiply. First, you're going to switch the x and the y. You're cross multiply, isolate y on one side, and factor the y out. This is what you're doing when you have an x in 2 places. So number 9, does this have an x in 2 places? I suppose we should graph it first. What is it, guys? Quantity x. X minus 1. Okay, if you were graphing it, you need parentheses top and bottom. And it looks like this. Does it seem okay? Pass the horizontal line test and vertical line test. All right. So the first step, I didn't write the first step down because the first step is the same for every inverse. It's to do what? Yes. Change this to say x equals y minus 1 over 2y plus 5. Now we're on my list of steps here. First thing I want to do is cross multiply. What is that going to say? X times 2y plus 5 equals 1 times y minus 1, which is just y minus 1. You do have to go ahead and distribute. So some of you probably would have distributed as you went. Just be careful. Now, when when I write isolate y, I need everything with a y on one side and everything that doesn't have a y on the other side. So what would that look like? Very carefully. Which do you want to move which way? Doesn't matter to me. You want to move that over to the... It actually doesn't matter. You get different versions of the same answer. Okay, if I subtract the y over here, I'll have the 2xy over here, and I'm going to subtract this y over to this side. But what am I going to do besides that? I got to move that over there, but it's going to be done by subtracting. So I'm going to have a negative 1 minus a 5x. Then what? There's a lot of people on their phones right now. Take out a y, and this would say what? 2x minus 1, be careful, equals negative 1 minus 5x. Last step? Yes, divide by 2x minus 1. So I get y equals negative 1 minus 5x over 2x minus 1. And I'm just going to leave it y equals. I don't think we should take time to rewrite it again. Now, don't write this down because it'll confuse you on your paper. But if back up here, who said we should do it differently? Somebody said right here, was it? Kayvon said we should move it the other way. Okay, if we had left the 5x on the left and added the 1 over there, and then left the y on the right and subtracted the 2xy over there, and factored the y out over here, and divided. Some would say that looks a little prettier, but why are they equivalent? Can anybody tell me why these two things are equivalent? No, they are actually the same equation. All the signs are changed, right? So it's like you multiplied a negative 1 across the top and the bottom. So they are equivalent. Again, that's my job to figure out when I see your answer, is it equivalent to what I had or whatever, okay? So there are different right answers because they are equivalent. All right, composition of functions. This is when you're putting one into the other. If they are inverse functions, guys, when you put a function into the other, it's all going to cancel out and give you x. And if you go the opposite direction, it's also going to cancel and give you x. So this says if f and g are inverses, then putting f into g would give you x. And putting g, yeah, I said that backwards. I'm struggling today. Would cancel out and give you f, okay? So here's two functions, f and g. And they showed putting, okay, this is a nightmare. Putting g into f would be 6 over, what would you do first, guys? Right here, what would you do first? Nobody? This is not multiply, so those parentheses aren't really necessary. So plus 4 minus 4 would go away. Then you would have 6 is being divided by 6 over x. How do you fix that? Multiply by this, and what happens? Okay. Then if you did it the other direction, if I put this mess in this one, I would have had 6 over x minus 4, and there's a plus 4 on the back. Okay. How do I do this piece right here? I know y'all want to cry right now. I would have 6 divided by this, which means multiplied by the reciprocal. What happens? 6's cancel, and what's x minus 4 plus 4? Okay, that would be the one I didn't put on the quiz, okay? We're supposed to show that these are inverses, though. We can handle this. All right, you want to do f into g or g into f first? G into f, okay? So that would be written G into F would be this way. I'm just going to write it like this. G into F. So you'd have 2x minus 3 over 2 plus 3. You have to show some work, because there's one of these or two of these on the homework. You can't just write equals x. What are the proper steps? What would you do first here? Okay, but can't a multiplied 2 and divided 2, right? So then I'm left with x minus 3 plus 3, which is x. All right, now we need to go the other way. So how do we do this one? This means put f into g, so I have 2x plus 3 minus 3 all over 2. What happens first? Okay, so I end up with 2x over 2, which is x. Okay, that's showing that they're inverses. And some of them can be really ugly. I hope we don't have a really ugly one. No, we don't have another one. Good deal. All right, to graph an inverse, if you can find some ordered pairs, what are you going to do with those ordered pairs, guys? Yeah, reverse them. Okay, this one is really hard because this is -1, 0 to get 0, -1. This is 0, 1, so you get 1, 0. And this one is 2, 1, so you get 1, no, it's 1, 2, so you get 2, 1. It isn't very helpful because it looks like a line, right? If we tried to use one more ordered pair, what's this ordered pair down here? Like -1.8, -4? So it would flip and become -4. -1.8 would be like here. So this part, now can you kind of tell what's going to happen? Okay. It's got to reflect here, all the x's and y switch. You have to do one of these on the quiz, but it's not as complicated as that one, okay? So let's try these. You don't have these, I don't think, on your paper, but can you pick a couple ordered pairs? Like what's this one right here? 0, 3 would become what? 3, 0. This one right here is -2, -1, which would become -2. And since it's a line, I can just connect those. Does it look like it reflected across there, guys? Okay. Where's 0, 0 going to go? 0, 0. What does that look like? 35 maybe? Up 5? So it would be 5 up 30 would be going this way. It's just going to do this so that it's switched across here. You have to do this one, which is weird. One again. 0, 0 is going to stay where? Okay. 1, 1 is going to stay. 2, 2 is going to stay. All right. Let's try this one up here, though. That's like 3, 8 would become what? 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3. Okay, so from here to here, it's doing this. But what do we have to do here? We have to kind of reverse the little curve there so it's going this way. Because it's supposed to flip across this line. Oh, I can't draw that line. The line y equals x. Okay. I gave you a better one on the quiz, I promise. Okay, this is important in calculus, but it's not on our quiz. If you had a function like this, y equals x squared, how could you restrict the domain? So tell me I only want half of this. How do you say I want half? So that it's 1-to-1, it passes the horizontal line test. Okay, so I could say x is greater than or equal to 0. I want to keep this right half and get rid of this, which means we would probably say this. Would it be wrong to say I only want the left half? No, either one. Do we have to do another one of those, or are we good? Do you have this question? Okay. So this is the formula for Celsius to Fahrenheit and Fahrenheit to Kelvin. Oh, they want us to do the inverse of this and then the inverse of this. Yeah, I'm voting we're out of time too. All right. So guys, this is the assignment. It's on page 70, 2, 3, 4, 5, 6, 10 questions. The little homework check sheet? No, but I think I picked it up today. Okay. So I